Why does approximate pi reduce sphere calculation accuracy? Imagine trying to measure the size of a ball using a ruler and a rough estimate of a special number called pi. You might think your measurement is close, but small errors can really add up. When we work with spheres, pi is a key part of the calculations. Pi is a number that represents the ratio of a circle's circumference to its diameter. It is about 3.14159, but it actually has an infinite number of decimal places without repeating. Because pi is an irrational number, we can never write it down exactly, only approximate it. When we use a rounded version like 3.14 instead of the full value, it introduces a tiny error. Now in the formula for the volume of a sphere, which is for thirds times pi times the radius cubed, every part matters. The radius is cubed, meaning even a small mistake in pi gets multiplied 3 times, making the error much bigger. So, if you use 3.14 instead of the real pi, your calculated volume will be slightly off. This small difference might seem tiny, but in precise fields like engineering or physics, it can cause real problems. Using more decimal places or the exact pi value from a calculator makes the calculation more accurate. The same thing applies to surface area calculations for spheres, which also involve pi. Because spheres are three-dimensional shapes, their measurements depend heavily on pi. If you want your measurements to be as close to real as possible, using a more precise value of pi is the way to go. For everyday tasks where perfect accuracy isn't needed, 3.14 might be enough. But for anything that needs exact measurements, like designing a satellite or building a bridge, using the full value of pi ensures your calculations are correct. To sum up, pi is an irrational number with endless decimal places. When we use an approximate value, it causes errors that grow larger when we cube the radius in the formula. This is why using an approximate pi reduces the accuracy of sphere calculations. The more precise the value of pi you use, the closer your measurements will be to the true size of the sphere.